Okay, okay, guys. We are for the last talk before the break. Mihail, I don't know, clicker? Anyone? We are waiting for the clicker. So Mihail will talk with us about some fancy stuff. I can only say that he's very experienced speaker, and few years back I was on his talk about web, and his talk was maybe the best of the conference. So yeah, I don't know what to expect today, but I would expect a lot. Keep in mind that right after his talk is the break. We do not have included lunch on the conference, but there are a lot of options around. So there are 2 restaurants downstairs, and there is a Serbian thing as well, and there is on the other side of Carigradsku said there is another 2 restaurants as well. So if this talk takes more time, it's not a big deal because it's hour and a half break after it. So yeah, Mihail, the stage is yours.
Thank you very much. We're approaching the lunch event, so please don't fall asleep. I'm going to talk about AI. This is the most important topic, and let's approach it carefully. Who am I? My name is Mihail Petrov. I'm a PhD in computer science. Those are my network contacts that you can use in order to find me if you're interested to talk about AI databases, etc. I am practically living in this building, trying to educate the future of our society. The Faculty of Math and Informatics at Plovdiv University. During my free time, I am working as a head of engineering at Upia Tech. We are a Snowflake partner, and we're trying to deal on a daily basis with some database problems, mainly centering around Snowflake technologies. And the most proud achievement is that I am the founder of the first located in Bulgaria and the Balkan Peninsula Bulgarian user group centered around Snowflake technology. So if you're interested in this topic, we can always gather around and share some ideas related to cloud computing and cloud technologies. Last week, we actually hosted our first event at Plovdiv, and it was pretty amazing. We gathered a lot of people that are passionate about this technology. So I believe this, the crowd in this building is going to be a perfect vector for our future society. Quick quiz. Raise your hand if you never, ever heard about Snowflake cloud platform. Let's see. Oh, perfect. We are dealing with some very knowledgeable crowd. So Snowflake is the topic of this event. We're going to talk about talking. We're going to explain how to actually communicate with our database. One of the very interesting idea that I'm currently captivated is this cloud technology and also cats. When we combine cats and snowflakes, we have a snowcat, and in the shadow of the today presentation, I am going to deal with the idea how this particular platform is going to help us actually create products that can benefit our daily life. For those who actually raise their hands in order to demonstrate publicly that they are not familiar with Snowflake, I'm going to just state that Snowflake is a modern cloud-first infrastructure/platform that can give us every single aspect of data storage, data integration, data analytics, and the whole ETL process. But today, we are going to face the AI revolution. It happens It's wild, it's everywhere. We're not interested anymore in shiny new languages. We are interested only in large language models. This is the reason that I'm going to focus only on this particular aspect of the platform, the so-called Snowflake Cortex AI, and how to actually use this in order to create products. Of course, because the time is limited, we are going to only scratch the surface, but I believe this is going to be a very interesting foundation for future communication. So we all experience this problem on a daily basis. We are trying to communicate with our database. Usually, the medium is a single one, SQL programming language. But what about the people who are not familiar with SQL, or those of you that do not wish to even remotely approach this language because it's too chaotic, it does not look like Java, it's too strange or complicated, and the learning curve is extremely steep and strange in a long run if you're dealing with something complex? Well, usually in this case we are shouting and cursing, and we are trying to approach this in a more meaningful way. So in this case, we need to actually look at a different approach to this very problem. How to communicate with the database using our natural language. In order to actually understand this, we need to search for answers a little bit outside of the scope of the traditional databases. So we are going to approach the vector databases, the so-called odd ones in the bunch. So usually, when we are trying to communicate with our data, imagine we are talking about ChatGPT or another large language model, we always have three different types of options, of ideas, of items that are working together. We have the data, we have the model, and we have the embeddings. The data can be everything: images, text, video, audio files. Useful information. The model is the so-called large language model transformer. So this is the piece that can actually get these words and attach meaning to them. And of course, the end result is actually the embedding. The embedding is a magic set of vectors, numbers, that can actually make sense not for us, but for the database. Those numbers that you can see on your screen, they can be everything in relation to the language. But this is going to be important just in a bit. So by actually using those three aspects, we can transform images, texts, audio files, and video files into a vector in which we can communicate. Because at the end of the day, we just have a bunch of arrays of numbers that for a particular large language model means something semantically. So the idea is extremely simple. We get a bunch of data, we've put it in our database, vector database, and we can ask question the same way that we are currently asking ChatGPT, for example, or Gemini. There are a lot of vector databases that we can use. On a market, usually every single platform have a preferred way to actually introduce this to their database. We are currently going to face only the Snowflake aspect in the second column because the vector database is built in the platform, and we don't need to introduce anything separate in this case. So as I mentioned, Snowflake gives us Cortex. So the Cortex is a bunch of functions. You can think about a library or a framework of different ideas, patterns, and functionality that can come together in order to extract information from text. We have LLM functions, copilot type experience chat, so to speak. Document AI, which means a detailed analysis of a random document. We can fine-tune, analyze, and search in documents with a multi-purpose scenario. So we can search in images, we can search in text, we can search in audio. And also we have a bunch of ML functions that can be used in order to train some models in order to get a little bit more semantically meaningful information. This is the platform in a nutshell. The Cortex AI gives us this from scratch. We just need to have a Snowflake account, we just need to connect it, and from this point on, we can use it directly, utilizing not only Snowflake proprietary models, but also some of the most popular under the sun. The OpenAI models, Gemma, Mistral, etc. So this was actually introduction. The idea that we are going to use a platform to solve our problem. But let's go to the practical cases. Let's talk integration. Some business use cases that I've actually trying to wrap my head around for the last couple of, let's call it months. It's over 12 months, so an year and a half. So me and my wife, she's a real vet. I'm the strange person with the Snowflake account. We've decided to help the veterinary practitioners to actually extract meaningful data from their patients. So imagine we have a veterinary practice, a single cabinet with a single doctor or a multiple doctors who are on a daily basis accepting different visits from customers. They are always examining patients, cats and dogs, and they are up to their eye in different documents. It's a lot of work on a daily basis, a lot of information that someone needs to keep track of it. So, what is the solution? We've created something called Vet Manager. This Vet Manager is a simple application on your phone, and you can imagine it as a glorified Wikipedia for everything that is happening inside this particular practice. We're using this application in order to solve 3 different problems. How to give us specific information about medical facts. We need to collect and filter super specific information about our patients. And of course, we need to explain the current state of the patients to some normal people that have questions. For example, the owners of those pets. You can imagine that if you're a young veterinary practitioner who is currently challenged with the state of the medicine, you're always struggling to remember what was this magical ingredient that I need to give to my patient. How to actually solve their problem. It's not easy, and usually those information is collected in some legit medical books. So our first use case is simple. I wish to have a software that can answer me a specific medical questions. If you ask ChatGPT, yeah, you're going to get the answer. But what if I told you that I've spent thousands of dollars to obtain limited medical books that are not available to ChatGPT, and I wish to use them in my practice? Those limited books can be obtained using different methods like attending seminars or buying them from some limited publishers, etc. Not publicly available information, not internet material. So, how to solve this problem? One of the solutions is the so-called RAG. Retrieve, Augment, Generate. So, in layman's term, the large language model do not have enough memory to contain everything that we need to know. It's limited at its nature. But what about an extra container of memory that have all of those valuable information that I need to extract at any given moment? So this is the moment that we are introducing our external documents. We have a bunch of books which needs to be embedded in the vector database, in this case, the Snowflake's Cortex. And from this point on, I can ask the large language model, do you know this extremely specific topic about this extremely specific disease, for example? Practically, this means that I have a number of books, specialized medical books, in PDFs or in different type of documents. For example, lectures in video format, or lectures in audio format, or lectures in whatever format. And I need to actually split them into different chapters that I can actually feed the database. Let's get this textbook of veterinary medicine. Let's split them to chapters. Chapter 1, basic examination. Chapter 2, different diseases in cats and dogs. Chapter 3, whatever. So we are creating a database, we're creating a schema, and in our personal Snowflake storage, we can put every single one of those PDF files that we currently have. Surgical files, cats and dogs, canine bone growth, etc. Every single literature that I'm currently obtained, it's part of my Snowflake environment. I've updated it, I've uploaded it, and I can start rugging it. The basic process is when I have a PDF file which is part of my stage, I can actually extract information directly from those files without the necessity of actually introducing the model to this particular file. I'm not going to say, get from this column or from this row a particular information. No, it's just a pool of data. So I can use a Snowflake-specific functions like parse document in order to extract the information. I can split it into different chunks, and I can create a pseudo virtual table that is going to act as a memory pool. In this case, every single chapter is embedded using E5 base V2, which is a standard algorithms in Snowflake Cortex, and the result is going to be a bunch of arrays full of numbers. Those arrays are going to be additionally chunked, metadata hydrated, manually, or as we factually understand in the last lecture, it's possible to create a fully automated process. And actually, at the end of the day, we're going to have a huge extra large language model brain that we can directly query. So if, for example, our young practitioner asked the application, or in this case the Snowflake, what are the symptoms of ehrlichiosis, which is a disease in the cats and dogs, I'm going to receive information directly from the Snowflake LLM using this embedding that I've just created with my PDF files. So if we actually observe this in a context way, so the same way that we are actually approaching ChatGPT, imagine that every single time we ask the model, we are sending something like this. You're a veterinary assistant or consultant, and you're going to use this medical context that I've just presented to you. Whenever you have any doubt, don't know the answer, or have even the slightest uncertainty about the accuracy, you're going to provide me information about this. I don't know, I'm not sure, I'm going to feed you something that is factually wrong. When returning information about this concept or context, always include a link to the document in order to actually check the PDF if this is correct. When returning information about a patient, if I ask, for example, what's happening with Gosho, what is the current state of this particular animal, always include a link to a patient profile or patient dossier. And this is integration on so many levels, because the AI is not going to only answer questions, it's going to be integrated in our database system, and we are actually getting everything outside of the box. The LLM in the Snowflake and the database, which is also in Snowflake. Second use case that we have. The software needs to aggregate data about the patient current and past state. This is a dynamic data use case. Usually the problem when dealing with extreme amount of information about patients is a historic accuracy. Somebody actually introduced a mistake in the protocol, or we didn't type it on the same day, and in the long run, we forget something. Is this animal is actually treated for these specific diseases? What was the weight of this animal when first he or she approached the practice? We don't know. And usually, we are too busy to type something on our computer. The doctors are pretty busy. Usually when we have the image of a doctor, we are usually imagining someone who is going to treat us, not type on the computer a specific state of the current patient. So what is going to be the best approach? To just record the thoughts during the whole examination. For example, I am examining the patient and I am dictating. This patient is named whatever. It's of X weight and X height. It have the past symptoms of this and this and this. And this information is going to be recorded. And from this point on, the recording can be treated as text. So Snowflake gives us the ability to actually collect information from whatever type of format. In this case, we can use a speech processor using the AI transcribe to get this information as a voice, directly transforming into text, and from this point on, we can create protocols, or we can ask questions about this specific use case. And because it's a verbal, we're not going to miss anything. We can just communicate with the owner. The owner testimony is going to be on the tape. And every single conversation that we have with our colleagues is also going to be on tape. Nothing is going to be lost in the translation. And this information is available in Bulgarian. So every single practice that currently integrate our software can actually talk in their own native language without the necessity to actually introduce some external language just for the application. So speaking in Bulgarian, speaking with a client, we are going to get the whole conversation ready to be analyzed and ready for questions. So in order, for example, to extract this information, we can use a simple select query, AI transcribe. We are addressing the file that can that can be obtained dynamically. For example, we have a medical consultation and consultation.waf file, which is a result of a particular recording. And the result is going to be an audio duration in seconds and some text that can be used to further analyze the situation. Also, we can actually extract different segments. So every single words or sentence can be further chunked and analyzed if we wish to have extremely lean result based on our expectation for the model. Purely from UI's perspective, every single file that is providing a multimodal capability, in this case video, audio, etc., can be directly observed inside the Snowsite UI, which is part of the Snowflake UI suite. And from this point on, based on queries or based on natural language, we can communicate with this particular document. In this case, I am presenting a semantic modeling in which we are trying to actually describe from which point of the conversation to which point of the conversation we wish to feed the model in order to fine-tune it a little bit later. This is a simple meeting analysis that is a part of the application. So everything that's happened is actually visible inside the Snowflake interface. What question do you have the meeting? What is being discussed 5 minutes into the meeting? And every single one of those questions that you can see is something that we've asked the model. We can ask it in Bulgarian, we can ask it in English, we can ask it in every single language that you've just saw listed on the screen. And the third and final use case that we've tackled in our journey, trying to make the veterinary medicine a little bit more digital, is the software needs to aggregate data in relation to our internal processes. This is a combination between static data and the dynamic data. In which case? So the dynamic data is everything that is actually working in our practice. We have some patients that are experiencing different diseases. We don't know what is going to be the exit of a particular procedure. It can go right, it can go wrong. We have some ideas what's happening or how we can approach this in a different manner. But every single part of this is dynamic data. We also have our rack data that we have explained in the first use case. Everything that we've collected during the years, something that is not going to change, something that is static by nature. Documentation, patient's protocol, surgical information about different patients, internal protocols, drug info, for example. Every single medicine practice is using a little bit of different way of mixing their ingredients when they're trying, for example, to apply anesthesia or, for example, to apply different medicine to a particular weight of the patients. This is information that you cannot find in Google. This is information that is provided by the clinic. So in this case, we have different sources of information. It can be a lot of different sources. Different source of dynamic information, different source of static information. For example, we have the combination between textbook and list of drugs and internal procedures. This combination, interestingly, can be additionally mixed with our first approach. We have the application that is communicating with the Snowflake Cortex. This is the LLM. We have the initial embedding, but we also have a separate embedding for every single use case. So we are not only going to attach metadata to a specific chunk, but we are going to create a completely separate sources of information, completely separate memory banks that can be asked additionally for some question. And for example, we can ask, what is the cost of a surgical procedure for so-and-so breed of dog? Versus what is the cost for surgical procedure for a dog that is named in particular way. The first case, I am asking a general question about a breed of dog. So for 10 kilos of dog, for 12 kilos of dog, for larger breeds, smaller breeds, etc. On the other hand, I am asking question regarding a particular patient that we are currently dealing with. So the dynamic data can actually go through different sources in order to find the best case. And this is actually the hard part when we are trying to fine-tune, because separating the extremely different information into a memory bank usually poses a challenge when we actually merge the end result. So usually we are trying to optimize. The optimization happens when we are dealing with so-called summary reports. Every single source of information is also collecting a summary of this information. It's going to be a light lookup table that is going to give us information or the answer of the question, yes, this is the right source for you. Or no, this is not the right source for you. The customer is actually asking for something completely different. Because the surgical memory bank containing information about medical books can have some overlapping with internal procedures. For example, in the textbook, we can read something like, you need to make an incision starting from the second rib. But our internal procedure is telling us, no, we are starting from the third ribs because this, this, and this. So when we are asking question, always the internal procedure is going to be the main source of information. But our LLM needs to know this based on the summary report. Also, we can introduce agents. Snowflake Cortex gives us ability to spin different MCP servers or different agents that can actually, in parallel, check our sources and give us the answer of the question, yes, this is the correct source that you are using at the moment. In conclusion, it's a complicated topic. As I mentioned, we only scratched the surface. I've shared with you an idea, a practical use case that I'm dealing the last couple of months. And if you have more questions regarding how we've built it, what was our assumption, and how to actually approach something like this in your own project, you can find me after the lunch and we can talk about this. So thank you very much for your patience.